Hi everybody! After a long absence, I'm back again to talk about one of the newest topics in NLP, controllable text generation. Today's article is a survey of controllable text generation using transformer-based pre-trained language models by Hanqing Zhang, Haolin Song, Xiaoyu Li, Ming Zhu, and Davi Song. I hope I pronounced their names correctly. This article is published in Computer Science in 2022. One of the important branches of natural language processing, NLP, is natural language generation, NLG, as a complementary for natural language understanding, NLU. NLG technologies play a crucial role in a range of applications such as dialogue systems, advertising, marketing, story generation, and data augmentation. NLU aims to develop an intelligent machine that can read and understand human language, while NLG enables computers to write like humans. Making text generation controllable is an important and fundamental issue in NLG. A NLG system should be able to reliably generate text and meet certain controllable constraints as the humans wish. In recent years, the development of deep learning, DL, has given rise to a series of studies on DL-driven controllable text generation, CTG, which has brought genuine breakthrough in this field. Early approaches are based on sequential models and style embedding and achieve some promising progress. After that, there's a surge of methods based on deep generative models such as variational autoencoders, generative adversarial nets, and energy-based models. However, the success of the above DL-based methods rely heavily on large-scale datasets, posing a challenge for supervised and cross-domain text generation tasks. Since 2018, large-scale pre-trained language models, PLMs, such as BERT, Roberta, GPT, T5, and MBART have gradually become a new paradigm of NLP. Owing to its use of large corpus and unsupervised learning based on the transformer structures, PLMs are believed to have learned a great deal of semantic and syntactical knowledge from the data, and only fine-tuning is required for downstream tasks to get the state-of-the-art performance. Pre-trained language models are neural network-based, which essentially are still black boxes, lacking a good level of interpretability and controllability. How to improve the interpretability and controllability of the PLM-based models for generating text has become a hot research topic. This paper provides a brief introduction to the two key aspects of area, the concept of the controllable text generation and pre-trained language models, and also the main tasks and evaluation metrics related to CTG. After that, they divide the main approaches to PLM-based controllable text generation into three categories and discuss them in more details. So there's a dedicated and comprehensive literature review on CTG approaches using PLMs, and finally an outlook on the possible future research directions. A typical CTG system consists of three components: a controlled element including controlled condition and a source text as input, a generative model as process, and a generated text satisfying the input control condition as output. In the next part, authors introduce typical tasks related to controlled text generation, which are attribute-based generation, dialect generation, storytelling, data-to-text, data augmentation, debiasing, and format control. Then they talk about transformer-based pre-trained language models. During the pre-training stage, the use of large-scale unlabeled data can provide a strong support for an increased model scale and make the system better grasp the deserved knowledge in the data. State-of-the-art performance has been achieved in downstream tasks by fine-tuning the PLMs based on only a small amount of supervised data. Authors divided the PLMs into three categories: autoencoding models, autoregressive models, and seg-to-seg models. Researchers provide a comprehensive review on the main approaches to PLM-based CTG. The core idea of PLM-based CTG is given the model a control signal in an explicit or implicit way to drive the generation of tasks satisfying the control condition. According to the way how the control signal works, they have roughly divided the existing methods into 3 categories, each of which is further divided into several subclasses. As we know, the performance of a model is reflected by suitable evaluation metrics. So in the next section, researchers discussed about general and CTG-specific metrics to measure 4 general evaluation aspects, which are fluency, factuality, grammar, and diversity. They divided general metrics into 3 categories: human-centric evaluation metrics, automatic evaluation metrics, and semi-automatic evaluation metrics. But the CTG task demands extra evaluation metrics that takes into account the controlled elements. So typical ways to measure the effectiveness of a CTG model are accuracy, keyword base, LM base, and Jensen-Shannon divergence. Finally, they discussed about 5 PLM controllable text generation challenges and suggested future directions as follows: prompt-based learning, fine-grained decoding control, integration with classic generative theory and linguistic knowledge, incorporation of knowledge graphs, and novel evaluation metrics and methods. There are lots of details in this paper, so if you are interested in the topic, don't miss it.